This is the TDM Today show starring Roger Magoulas. Hey, Roger, how you doing?
I'm doing great. How are you, Carl?
Just fine, just fine. Thank you. So we talked about entity recognition last time. We're looking for names of chemicals or places. I'd like to talk about keywords today. How do you know what an article is about? How can you say I'm looking for all articles about this or that?
Yeah, it's actually a somewhat difficult problem, but it ends up statistics can help. And that's what we use. We use some statistical methods to figure out a summary of what are the important topics in an article. So how do you figure that out? Well, there's actually a technique that is actually behind how Google works, called TF-IDF. It stands for Term Frequency, Inverse Document Frequency. And what it basically does is it measures how often a term appears in a document and how rarely that term appears in a corpus of documents. So when you combine those two things, if a term appears a lot in a document and it doesn't appear in a lot of other documents, that document is probably important to it. So we assign a score to the unigrams we've talked about. That gives you some sense of this is how you might summarize things. So you could pull off the words that have the highest TF-IDF ranking, and then those are keywords. There's also other algorithms. There's one called Yake that uses statistics and some contextual awareness. In fact, some of the kind of entity things and how the types of words or the pronouns and nouns, parts of speech and stuff like that. And we're trialing that. We're seeing how Yake does on keyword. There was one I loved. It's a spatial graphical rank called SG rank, but it was so computationally intense that when I started calculating how long it might take to go through our corpus, there was end of time scenarios involved. So you have to pick methods that do their best and also can happen quick enough that they're useful in what we're doing. It's funny, there are people doing great work on summarization, and we're able to ride on the backs of some of that. Now, what that does in a nice way is that, with a plant name, if it just appears in a doc versus it's important in the doc, is a nice thing for a researcher to know. And this is where keyword algorithms really help, in that you know that something is more about that topic.
So word is in an abstract. Is it more likely to be what the article is about, or do we search the whole article? Do you focus your search for keywords in a certain part of your corpus?
Brought up a very important point. I search the whole document, so I include the abstract and the document. And Yake, and there's another thing called positional rank, looks at the beginning of an article and puts more weight on the words that appear there. So it's absolutely true that those usually give you some indication that there's more there. Now we may experiment some with using maybe even more weights on the abstractions than the text of the document. But right now, because in some cases not that they're obscure things, but we're looking for very particular things, they might not make it to the abstract. They might be more embedded in. And you can imagine scenarios where a researcher wants to know that what they're looking for, what the context of how that species or chemical or whatever is used. And it might not appear in the abstract. It might be more embedded in the article. So we, in a way, want the keyword things to be a little greedy and maybe like overdo it. But the nice thing it does is, I think it's not quite 10 to 1, but you have far fewer terms to search through to figure out whether you're finding the thing you want. And sometimes that's a value too. I can imagine a scenario where we first start looking through keywords and see what works there, and then work through the other ways that we've pulled data from the corpus that we're looking at.
So in the old days, if you look at something like the Library of Congress, subject matter card cataloging, they would create ontologies. They say, if you're talking about this, you're also talking about that. If you see Trump, you're also a Republican politician. Are we using ontologies now, or are we just using statistics and machine learning in the internals of our corpus?
Yeah, we are just using statistics at this point. And at some point, I can imagine taxonomies and ontologies, and they're just slightly different, although they're often used interchangeably, where because we know a lot about the subject, we would use those to help us work things out. The Freebase, the company that Google bought and now puts stuff over on the right-hand side sometimes when you do a search, is an example of they have ontologies that try to figure out what it is you're searching about and bring up some relevant information. That work is pretty interesting. It's also pretty computationally intense, and we have a big corpus. So that's something that we'll be looking at more in the future. But it certainly, taxonomies really help. And I have a lot of experience in what used to be called data warehousing, now more data science. And I think taxonomies and ontologies are more used and less talked about than any other topic in that space. That we always end up using taxonomies and ontologies to figure things out. I'm working on something now where I've got the plant genus and I've got the plant names, and I'm doing a search for the genus to put guardrails around how big my search is for the plant names to try to speed some things up. And that's an example of I've created a taxonomy without formally doing it, but I've done it.
So very quickly, one last question then. What's the difference between a taxonomy and an ontology?
A taxonomy is more hierarchical, and an ontology is a little more, that it's loose, but it just captures the relationships between things. So it's kind of an object, relation, object model, where taxonomies tend to have a top and then goes down. So the species, genesis and so forth, and families are taxonomical. And ontologies are more free-forming to do it. In many cases, I can tell you one reason taxonomies end up being somewhat more valuable in one realm, and that's when you're doing analytics, is that the hierarchy is kind of helpful. When you have ontologies, you end up getting a lot of disambiguation problems and things that are double counted.
There you have it. Thank you so much. Roger Magoulas, this has been the TDM Today Show. Thank you.
Thank you, Carl.
Our work at Public Resource is made possible by a generous grant from Arcadia. Arcadia, a charitable fund of Lisbeth Rousing and Peter Baldwin.